We are now introducing a topic in chemistry known as nomenclature. And nomenclature involves both naming and writing the chemical formulas of compounds. It's a very important skill that you'll need as you move forward and exploring the rest of the topics we'll be looking at through this course. This information is found in Chem 2A in Chapter 6, and in Chem 22 it is found in Chapter 5. Now when we look at nomenclature, naming or writing the chemical formula of a compound, the very first thing we have to recognize and determine is what type of compound are we looking at, because the type of compound determines the nomenclature rules that are used for naming that compound. So you can see I have up on the board 3 categories that we would place a compound in and then use the rules for that category to name the compound. The first category is ionic compounds. This type of compound is immediately recognized because the formula involves a metal cation and a non-metal anion. And we just finished a discussion of ionic bonding that holds metal cations and non-metal anions together in an ionic compound. So it's all closely related, bonding and nomenclature. Molecular compounds is the second category, and we recognize that a compound is a molecular compound because it contains non-metal atoms only. The bonding, therefore, involved in molecular compounds is covalent bonding, and we just finished a discussion of that. The last category is acids, compounds that we classify as acids. And I'm actually reaching ahead at this particular point in our discussion because we will not get to the concept of acids until much later in this course. However, we're going to be using acids and talking about them throughout the rest of the class. So I want you to recognize them, what their formulas look like, and how to name them. You immediately recognize that a molecule is an acid because its formula begins with hydrogen. And acids are found most often dissolved in water or in what we call aqueous solution. And we symbolize that the acid is dissolved in water by giving it a subscript AQ for aqueous. Looking at examples of these compounds, sodium chloride, iron 3 nitrate, looking at their formulas, we see the metal cation, non-metal anion in both of these compounds, putting them in the category of ionic compounds. Looking at this set of examples here, water, carbon dioxide, and ammonia, we look at the elements, the atoms that are found in these compounds, and see that they are non-metal atoms only. Therefore, that places them in the category of molecular compounds. And lastly, with acids, we see examples here of HCl, hydrochloric acid, acetic acid, HC2H3O2, indicating that both of these substances are dissolved in water, hence the AQ. And as soon as you identify that the formula begins with hydrogen, you know that you are looking at an acid. So when you are naming compounds, the first thing you must do is identify which of the 3 categories above the compound belongs to. And then you'll use the nomenclature rules for that category to name the compound. Let's do an example here. I have listed 8 different compounds up on the board, and I would like for you to classify each of the compounds as either an ionic compound, a molecular compound, or an acid. And you can pause the video at this time and just try your hand at categorizing each one of these substances, and then join me as we go and take a look at the answers. So looking at number 1, we see carbon, 4 hydrogens in the formula. We recognize that carbon and hydrogen are both considered to be nonmetals. Recall that even though hydrogen appears on the periodic table to the left of the stair-step line, along with where metals are grouped, hydrogen is considered to be a nonmetal. So looking at the formula of CH4, I recognize that there are only nonmetal atoms present. The formula does not begin with hydrogen, so I'm going to classify CH4 as a molecular compound. Looking at example number 2, BaCl2, barium chloride. I look at this formula and I see immediately that barium is a metal and chloride a nonmetal. So I'm going to classify barium chloride as an ionic compound. Looking at the next example, I see sodium, a metal cation, and hydroxide, a polyatomic anion. So number 3 would also be classified as an ionic compound. Number 4, looking at the formula, I see it begins with hydrogen. So this substance would be classified as an acid, specifically sulfuric acid, because the formula begins with hydrogen. Looking at number 5, once again my eye is picking up a metal cation, and recall that although aluminum is touching the stair-step line, placing it in what we would think is a metalloid or semi-metal category, for nomenclature purposes, we consider aluminum to be a metal. So we will classify this recognizing the metal aluminum and the non-metal polyatomic anion. We will classify this as an ionic compound. Number 6, I see that both phosphorus and fluorine are nonmetals, so I am going to classify this compound as a molecular compound. Number 7, 2 immediate clues. The formula begins with hydrogen. We see that it is an aqueous solution, so number 7 would be an acid. And then lastly, number 8. Number 8's tricky. If you look at number 8, you see the elements nitrogen, hydrogen, and chlorine. And all of those elements are nonmetals. So your first instinct would be to classify number 8 as a molecular compound, but that would be a mistake. I gave this example specifically because NH4+, the ammonium ion, is the only polyatomic nonmetal cation that you need to be aware of and have a radar signal up for. Whenever you see the ammonium ion, this is a cation, and it's in a compound with an anion, the chloride anion. So when you recognize the ammonium ion, that is a flag to you. It is a cation, even though it contains non-metal atoms only, and it would be in combination with an anion, making it an ionic compound with ionic bonding, holding it together in a 3-dimensional array.